We're going to start chapter 5, which is all about polynomials. So we're going to start by classifying them, adding and subtracting them. So first there's a bit of vocabulary we've got to get through. First vocabulary word is the word term. A term is just a number or the product of a number and one or more variables raised to a power. So when you look at those examples, 18 is considered a term, z is considered a term. If we had negative 4x squared, that's considered a term. Even a decimal in front of some variables, 2.5x to y to the third would be considered a term. And then a over 3 is also considered a term. So we could come up with a lot more examples, but all of those are either a number or a variable or several variables raised to a power. All right, a coefficient hopefully is something you would know. It's just the number in front of the variable. And so in the problems above, well, let's do a new example. I'm sorry. Let's just do a new example. If we had something like 4x squared, the number in front, the 4, is considered the coefficient, right? It's just a number in front of a variable. A constant is just a number with no variable. So if we just had something like 3, that's just a constant. Or if we had something like 4x plus 3, then the 3 is considered the constant, right? The constant term. So any number that doesn't have a variable right next to it is considered a constant. Now, like terms are terms that have the same variables raised to the same exponents. So for example, if we had something like 4x and 3x, those are considered like terms. Or if we had something like negative 2x squared with a y, and then we maybe had 4x squared with a y. They have exactly the same variable with exact variables and with exactly the same exponents. So those would be considered like terms, each of those examples. And later we're going to be adding or subtracting some polynomials, and we're going to be looking for like terms that we can combine. So it's important that we understand what a like term is. Now, a polynomial is just a sum or difference of terms. So if we have something like 3x minus 4x squared plus 2, we have taken a bunch of terms and connected them with plus or minuses. So we have created a sum and sums and differences here. And so if we have something like that with a string of terms together connected by plus or minuses, we have created a polynomial. Now the degree of a polynomial, the degree is the term with the greatest exponent. So up above, the degree is a 2 because the biggest exponent I see is 2. So the degree of this polynomial is 2. And if we write a polynomial in standard form, its terms should go down from highest exponent to lowest exponent. And so if we go back to that example where I wrote polynomial, we could rewrite it in standard form. So if we took 3x minus 4x squared plus 2 and rewrote it in standard form, we would have negative 4x squared plus 3x plus 2. This one is considered standard form because the exponents are going down. And make sure you don't want the coefficients to go down. The coefficients don't need to go down, just the exponents need to go down. All right, so there's some vocabulary for you. And what we're going to ask you to do today on your homework is we're going to ask you to take a polynomial and name it. And you can name a polynomial by its degree and by its number of terms. So you can kind of give it like a first and last name. So the first name, if we look at the degree, remember up above what degree is. It's the largest exponent. That's what the word degree means, right? So if we have an exponent of 0 or an exponent of 1 or 2 or 3, we give it a special name. So an exponent of 0 is considered a constant term. And we'll talk about that in a minute. Why on earth does it say it has an exponent of 0? Because constants don't even look like they have exponents. But I'll talk about that when we get down to example 1a. If we see, well, we actually wouldn't see, but if the biggest exponent that exists is a 1, which of course exponents of 1 are invisible, then that's called a linear term. If the biggest exponent we see is a 2, we call that quadratic. And that's kind of misleading. Quad just sounds like it should have 4, right? Usually things that start with the word quad mean you have a degree, you have something with a 4. But in this case, for whatever reason, they decided that when the degree is 2, we call that a quadratic. When the degree is 3, we call that polynomial a cubic polynomial. And anything that's higher than 3, we just call it an nth degree, meaning replace that n with the greatest exponent you see. So if like you have an exponent of 5, it'd be a 5th degree polynomial. Okay? So we'll name some in a minute. But let's talk about the second name that you're going to give it. The second name is going to be based on the number of terms. So if you have only one term, you call it a monomial. If you have 2 terms, you call it a binomial. If you have 3 terms, you call it a trinomial. And anything higher than 3 terms, we're just going to go back to the generic word polynomial. Everything we're going to be talking about is considered a polynomial, but monomial, binomial, and trinomial are a little more specific. So we want to give it the most specific name possible. So in example 1, it says name each polynomial by degree and number of terms. So a minute ago I said a constant, which 6 is a constant because it has no variable on it, is actually considered a degree of 0. And let me tell you why. Not that you really, moving forward, probably need to know why, because everybody knows what a constant looks like usually. But the reason it's called a degree of 0 when you have a constant is because you could rewrite it as 6x to the 0 power, or you could have picked any variable you wanted, but I'm going to stick with x. And remember that x to the 0 power is really just 1, right? It's really just 6 times 1, which equals 6, right? We learned this in the last chapter. So that's why we say a constant is really to the 0 power, because it could be rewritten with a variable to the 0 power, and it would still come out to the same exact constant. So this first one, if we give it, again, we're going to look at the degree and the number of terms. So it has, again, a degree of 0 because it's a constant. So we're going to call that a constant. And there's only a single term there, right? It's just a 6. So it's a constant monomial. That's how we would name example 1a. All right, example 1b. If we look at the degree, remember that's the largest exponent you see. I now actually see an exponent. It's a 3. So I'm going to call that a cubic. And again, I only see one term. And the reason you know you have only one term is because there's no plus or minus signs in this. Remember that if we want to connect terms, we put plus and minuses between them. So since I only have one term, we call that a cubic monomial. All right, in example 1c, the largest exponent I see is a 4. And notice when it's higher than 4, or higher than 3, we call it an nth degree. So I'm going to call it a 4th degree. That's its first name. And then there are 3 terms, right? There's 3 things being connected with plus or minus signs. In this case, 3 things connected with plus signs. And so that's a 4th degree trinomial. So the first name is based on the degree, which is the highest exponent you see. And the second name is how many terms are connected together. All right, in the next one, 5x plus 9, I don't see an exponent. Remember, there's really an invisible 1 on this x. So if we go up to the table, if we have a degree of 1, that's called linear. So we have a linear. The second name, we go over to the second part of the table. The second name is based on how many terms do you have. You have 2 terms connected with a plus sign, so that's called a binomial. So we have a linear binomial in example 1d. In example 1e, the biggest exponent I see is a 2, which again, this is a misleading name. I don't know why they named it this, but it's called a quadratic. And honestly, this is what we're going to be looking at the most. We're going to be looking at quadratics, and we're going to be factoring them, and we're going to be multiplying them. So we are going to do a lot of work with quadratics. So again, that exponent of 2, we're looking here, that exponent of 2 means it's quadratic, and then there are 1, 2, 3 things connected, and so that means it's a trinomial. All right, last one. The biggest exponent I see is a 3, so that's cubic. And there's 4 terms in a row. Anything higher than 3 we just call a polynomial. So we're going to call that a cubic polynomial. And as I'm looking at these examples, I wish I would have put one out of order. I put all the largest exponents at the beginning. We didn't need to do that. We actually could have had the exponent, like let's rewrite c. If c was 3x to the third plus 8x to the fourth plus 2x, this still would be considered a 4th degree trinomial. So don't think that the first term is where you determine what degree it is. It's always just the largest exponent you see. So I kind of wish I would have written one of them out of order, but I didn't. Okay, so all right, on tonight's homework, I'm not sure how they're written, but always look for the largest exponent and then count the number of terms. All right, so that's one thing we're going to ask you to do tonight. The next thing we're going to ask you to do is we're going to ask you to simplify a sum or a difference of polynomials. And we do that by combining like terms. And so we've just come off the exponent chapter. Let's remember that when we were in the exponent chapter, we were multiplying things together. We were multiplying terms that had exponents on them. We were not adding or subtracting them. So you know how to combine like terms probably in junior high. When we combine like terms, we do not change the exponent, right? Do not change exponent. We're so used to changing the exponent from the last chapter, and we sometimes get confused when we move into this chapter. But do not change the exponent when you combine like terms. We only change the exponent when we are multiplying or dividing things. We do things that have exponents. All right, so if we look at example 2, you're going to see that we're either adding or subtracting 2 polynomials, right? So in the first parenthesis, it's like we have the first polynomial. So this is polynomial number 1. Plus in the second parenthesis, we have another polynomial. So this is polynomial number 2. So that's why we say we are adding or subtracting polynomials. In this case, we're adding 2 polynomials. So when you have a plus sign in between the parentheses, and it's going to be really important in this chapter that you recognize whether or not you have a plus, a minus, or nothing in between the parentheses. And we'll get to that later. For this lesson, we're only either going to have a plus or a minus in between our parentheses. So you'll have a plus or minus connecting 2 polynomials. If you have a plus and there's nothing else in front of the second parenthesis besides a plus, the parentheses really don't mean much. They really just mean that you're adding 2 polynomials, but as far as worrying about changing any signs or doing anything special, you really don't have to. Really, this could have been written as 5x to the third plus 8 plus 6x to the third plus x minus 3. You could have rewritten it without the parentheses. Now, I don't expect you to do that. I doubt anyone's going to take the time to rewrite it without parentheses. But if you do that, then it almost seems really obvious what the like terms are. The 5x to the third and the 6x to the third should be added. So we'll get 11x to the third. The x is all by itself, right? It doesn't get added with anybody. And then the 8 and the negative 3 should get added. And so we have a plus 5. Notice how I'm shape coding them. You don't have to do that, but I'm going to shape code them so I know what belongs together. And also noticed how I did the exponent of 3 first. Then I moved over to the x that had no exponent but really has an invisible 1 on it. And then I moved over to the constants. And that's what's called stating your answers in standard form. Remember, that's what it said on the front of the notes. When we're stating answers in standard form, we want the polynomial to be written with the terms going from highest exponent to lowest exponent. And so you should get in that habit of always writing your answers in standard form. I had the highest exponent first in this problem, then the invisible 1 exponent, and then you always end with the constant because its exponent is an invisible 0. All right, so be careful with something like b. And the reason I say be careful is because there's a minus sign in front of the second set of parentheses. And again, you're really just subtracting two polynomials here, right? You have polynomial 1 in the first parenthesis and polynomial 2 in the second parenthesis. But this time you're subtracting. And so this case, those parentheses are like they kind of mean something, right? It means that we are going to bring that minus into the parentheses, and we're going to subtract 3x, and we're going to subtract 5. So I think it's important to rewrite the polynomial when there's subtraction in between it. You should rewrite polynomial number 2 with all of its signs changed, because when a minus is in front of the parentheses, it's trying to tell you to do the opposite of whatever's in the parentheses. All right, if I combine my like terms, the only like terms we really have are the minus 2 and the minus 5. But remember to state it in standard form. First x squared, then the minus 3x, and then combine those constants into a minus 7. We want our exponents going down. We want to write our answers in standard form. All right, in C, I'm back to having a plus in between my two polynomials. So again, that really doesn't mean anything. A minus in between the polynomials means you have to bring the minus inside. A plus doesn't mean anything. And think about why. If you brought the plus in, it'd be plus a positive 12x squared, plus a negative 14x, plus a positive 19. Nothing would really change, right? You'd still have a positive 12x squared. You'd still have a negative 14x. You'd still have a positive 19. Bringing a plus in really doesn't do anything. Bringing a minus in does. It says take the opposite. That's what an opposite a minus sign means, but a plus means nothing. So you don't have to rewrite it without parentheses, but I'm going to do that. And if a problem like this, I'm going to guess nobody's really going to do this step when we have a plus in between the parentheses, but I'm going to do it. And I'm going to start combining like terms. I'm going to always start with the biggest exponent and work my way down. And so I have a negative 7x squared. I have a positive 12x squared. If I add those two up, I get a positive 5x squared. Next, I have a negative 18x and a negative 14x. If I add those up, I get negative 32x. And then finally, I have a positive 5 and a positive 19. A positive 5 and a positive 19 make a positive 24. Again, you don't have to shape code them like that. It's fine if you don't, but make sure that you combine the like terms, and when you do that, you do not change any exponents. When we add or subtract like terms, the exponents do not change. All right, got two more examples. In D, we're back to subtraction. So again, I'm going to warn you that if you're not going to rewrite it, you better know that in that second parenthesis, everything's going to change signs. So my positive 4m squared is going to be a negative 4m squared. My positive m is going to become a negative m. My negative 12 is going to become a positive 12. Subtracting means take the opposite, add the opposite. All right, so I'm going to start with my biggest exponent, which was a 3, and there is nothing else with a 3, so I'm just going to write it. The next thing I have is m squared, so I have minus 4m squared, and there's no other variable that has a squared. And sometimes when things get long like this, some people like to cross them off as they go. That could be helpful. Now I do have some like terms here, a minus m and a minus m, and notice how I'm always circling the sign in front of the number, or sign in front of the variable with the variable. That's because we want to really think of that as a minus and a minus. And remember, there's invisible ones here, so we can put them in if we need to see them. That gives us negative 2m. And again, if you want to cross them off as you go, that's fine. And then I have a positive 9 and a positive 12. If I add those up, I get a positive 21. So I always start with that biggest exponent and work my way down. All right, so that's a simplified difference of two polynomials written in standard form. All right, I just threw in one little curveball down here. Even if you have three polynomials, right? We have polynomial 1, We have polynomial 2. And we have polynomial 3. Just pay attention to the sign in between the polynomials. The first polynomial never changes, right? We're just going to write it because there's nothing in front of it. The second polynomial has a plus sign in front of it. We learned that that means nothing, so we're not changing anything in that second polynomial. The third polynomial has a minus sign in front of it, so that means everything inside that parentheses is changing signs. Negative 4r to the third minus 4 plus 8r. Now I'm going to look to combine like terms. I see the biggest exponent is a 3, so I'm going to grab the two terms that have a 3 as their exponent. I'm going to add up the numbers in front, and I get negative 7r to the third. The next biggest exponent I see is an r squared, so I'm going to take those and add them up. So I have a negative 6r squared and a positive 4r squared. That's giving me negative 2r squared. The next biggest thing I see is a 7r and an 8r. I mean the next biggest exponent I see. And that's a positive 15r. And then, oops, I missed one. What about this negative r? See, this is a good reason for shape coding, because then you see if you miss something. It's also maybe you want to cross things off as you go. That could help you if you missed anything. So I should have added up all the triangular things. So a 7r minus r is a 6r, and a 6r and an 8r makes 14r. And then always end with your constant. There's only one constant left, so it doesn't get combined with anybody. So when we're adding or subtracting polynomials, it's all about watching the sign that's in front of the polynomial to decide if you have to change any signs. And then we're going to add up the like terms. And the like terms means you never change an exponent. You just add up the coefficients and leave the exponents alone.